from my mother's ancestry who came from Sweden. I was an only child, born in Wichita, Kansas. I went through elementary, high school in Kansas, and then attended Kansas State University in Manhattan. Toward the end of that period, which I graduated from there in 1939, no, that was high school, sorry. I graduated in Kansas State in the class of 43 and had obtained a fellowship at the Institute of Gas Technology, which was associated with Illinois Tech, and was there for only one semester. The summer work program took me to Boston, where I spent the summer in Boston Consolidated Gas Company, and making insecticidal sulfur paste from sulfur obtained from the Thilox gas purification process. An interesting method of testing the paste was that I was to push a tubicor as far as I could into a barrel of the paste, and then they put the barrel on the switch engine, and after several days riding around the yard, I tried again. And the difference had something to do with the consistency of the sulfur paste. Back at Illinois Tech, the program was suspended, the academic program of the Gas Institute was suspended after I'd been there one semester because it was too difficult to keep the students out of the draft. And some of them went into the special program for civilian assistance to the armed forces, and due to the fact that I couldn't see well enough, I was rejected by the Navy, and I got a job at Standard Oil of Indiana out in Whiting. And after a month working with sulfuric acid sludges, having lost my trousers and shoes to the attack of the acid, I was asked to join the Manhattan Project, and went for a month to Columbia University while they assembled the mass spectrometer that I was to use. And this part of the project was involved with separation of boron isotopes. We did this initially with the mass spectrometer, having liberated the boron trifluoride from a complex with dimethyl ether. The complex involved dimethyl ether. We had really an upside-down distillation column. The light product came out the bottom. And later we used a neutron absorption method, which was quicker for determining the abundance. And we did concentrate the strongly neutron absorbing boron isotopes, B10, up to over 90%. There were lots of problems because it was sensitive to air and moisture that we were working with, and I believe I found a new compound. I think it possibly has been verified. It was BOF trimer. I believe it was a ring of boron, a six-membered ring of alternate boron and oxygen with fluorine attached to each boron. Well, when the war was over, I decided to continue graduate school, and having been influenced somewhat by the physical chemistry instructor at Illinois at the Gas Institute, a man named Bruce Longton, who had come from Berkeley, and having talked to Professor Seaborg, who was involved with the project at Chicago at the time, I was influenced to go to Berkeley. After interviewing various of the professors and what projects they had, I decided to work with, be tutored by Kenneth Pitzer. And again, got involved with boron, this time diborane. And this worked some while with deuterium exchange reactions. And from this, I got deuterated diborane and obtained the infrared Raman spectra and eventually a normal coordinate analysis, which I did then and have never done anything like it since. There were a few anecdotes which relate to that whole thing. While at Berkeley, they didn't buy the best doers. They weren't pirates. And I put my Raman tube with frozen down diborane in one of these dewars while I went home for dinner. And when I came back, I found that the dewar was defective and there had been a considerable explosion. And there were two other students in the room at the time, and one of whose apparatus, quite an elaborate vacuum system, was shattered by flying glass fragments, including his mercury rectifier, which was such a healthy thing. And there was another electrical engineering student making some, building a microwave guide for far infrared or rotational spectra. And whenever I came into that lab again, he left. He wasn't going to be around any more explosives. But the tour reminds me of a story that happened at that time. Professor Gibson was very troubled because every time he tried to pour liquid nitrogen from one of these dewars, it burst, it blew up. And he took his problem to one of the other professors who showed him that he could easily pour out of the dewar and not have any problem. And I think they finally realized that the successful person unconsciously rotated the dewar as he poured so that it never wet the surface. It just kept a gas film and he had no problem. Well, eventually I finished my calculations, done entirely with the mechanical calculator. It just took months, whereas today it would be done in a matter of minutes. But my professor, Pitzer, had gone off to Washington as a member of the Atomic Energy Commission, I believe, or anyway, he's associated with it. So after the dissertation was written, I had to get it approved all around, and it had to go by mail, and we were going to leave our housing there, and I sat every afternoon waiting for the mailman, and he finally says, "Is this what you're been waiting for?" And it was, and so we were off. And before that, however, I'd been interviewed by Texaco. In fact, at that time, I only had about 3 possibilities. for employment. One was Los Alamos, and I didn't think I wanted to go there. And another one was a local oil company. But my wife, which I hadn't mentioned until now, I met her at Kansas State, and our first child was born while I was a graduate student. She was from New York, so it was a fairly easy decision to go to the Technical Research Laboratory at Beacon, New York, about 75 miles north of New York City on the Hudson. And I was there. I worked for Texaco throughout my entire career, 31 years, and most of it was at Beacon, with the exception of 1 year on exchange to the Technical Laboratory in Ghent, Belgium. And then the last 4 years were at the Port Arthur Laboratories in Texas. Can we cut this? Cut it, fine. Manhattan Project at Columbia, although we were located at some distance from the campus in the Nash building. This was called the SAM project, Special Alloys and Metals, I believe, and a lot of it had to do with uranium. And the overall person, I think was in charge of this was Harold Urich. Another man, also a professor, was Martin Kilpatrick, and the physicist who was involved with the near-type mass spectrometer that we built and I used, I can't think of his name. I should like to mention some of the people at Berkeley that influenced me probably more than my professor was a fellow student that you all know as George Simmons. And we were very good friends, and we both had our first children and shared babysitting, and to skip ahead a little bit, while at Texaco, I was the liaison for a Texaco fellowship at Berkeley, so I was making annual trips, and for 5 of the 6 years that fellowship continued, one of George's students held it. When I arrived at the Beacon Laboratories, I entered a really special group that was headed by L.C. Race. And when we look back at those times, I think we were very fortunate to have such a group in industry. I think it reminds me of the early Shell group, the type of research that was carried on at General Electric and Bell Labs. And I think we had a situation that was indeed unusual, and it was a tremendous benefit to me. And we got immediately into catalysis, and at that time Texaco was involved with the synthesis project, following, well, more or less Fisher-Tropsch. And my first work was carbiding iron catalysts under various conditions and examining these by X-ray and electron diffraction. It's been so long I don't remember the sequence of things, but that was given up not long after I was there, and I studied acidity using ammonia absorption, really essentially temperature programmed desorption to get the distribution of acid strength. We also, while in the iron, it was the iron that we did a double labeling experiment with CO. We had molecules with C13 and some with oxygen 18. And then this was published, but I don't remember exactly the details of the mixing of the interchange of the elements between its soil molecules. I think one of the things was the influence of hydrogen fluoride on the strengths of acid acidity. And then I got involved with platinum, as used in reforming catalysts. And we used, in this case, sometimes the carbon-14 isotope, so we were counting the radioactivity. I did get involved to some extent with the infrared spectra of adsorbed molecules, which Dr. Eichmann pioneered in, and we made use of it in various ways for both the acidic catalysts and the supported metal catalysts, using adsorbed bases and carbon monoxide and other things. There was a period when I was about 2 or 3, maybe 2 years, involved with a fuel cell project. Texaco had a joint project on high temperature fuel cells with Texas Instruments. I occasionally spent some time down in Richardson, Texas. The idea was thought that we ought to use the high temperature cell with a molten salt mixture of carbonates as the electrolyte, immobilized, that we might succeed in using hydrocarbon fuels, not just hydrogen. We tried various anode materials, hoping to get a catalytic electrode that would consume carbon at somewhere near the theoretical potential at zero, very low current. And we never succeeded, and I'm not sure anyone has. It's really necessary to convert that by conversion to hydrogen, which can be burned, can be used near the reversible theoretical potential. The old physical research section, which I referred to before, which was a group of 7 or 8 people using X-ray, chemisorption, various kinds of infrared and physical UV spectroscopy, later augmented by NMR. At that time, NMR was not very good for solids. We were trying to apply it to catalysts. I understand nowadays we get double spinning and all sorts of things, and it's a very good tool for that purpose. We were very disappointed in what it could do then. And later we got ESR. And about that time, about after my stint in the fuel cells, which was in the early 60s, this this group was more or less broken up, and I was and only Dr. Ishins and a few others remained as a core. They were continuing with their own special interest. And I went over to the fuels group. And for a while, I was just coordinating with some of the physical and spectroscopic tools on their catalysts of interest. But I made one attempt to make a low temperature isomerization catalyst, because at low temperatures the equilibrium would favor the isomers which are desired for octanes and that sort of thing. And that one adventure was trying to make a complex, and it involved nickel carbonyl, which I wasn't too happy about working with, but we didn't have much success in that direction. And toward the end, I was working on hydrodesulfurization catalysts, mainly devising a microactivity test. But this, just prior to that, was my exchange year in Belgium, and there I first began to use the microreactor and the gas chromatograph and analysis of products. And when I came back, I used the same tools on the HDS catalyst. And I was working in that direction when, in 1976, we were moved as a group, or 5 or 6 people, to the laboratory in Port Arthur. And there I continued studying the hydrodesulfurization catalyst, using the microactivity test to determine the effect of various treatments of these catalysts and the variations of these catalysts. However, most of the catalysts were commercial products that we did not develop ourselves. And that continued until I retired in 1980.
Why were you using ammonia to characterize the acidity when you...
Well, ammonia was, this was really the thing that Bob Ishins pointed out. The people, there's a big argument of whether it's Brunstad or Lewis acids, and if you put ammonia on a Brunstad acid, you get ammonium, and it absorbs on a Lewis side, it's ammonia. So this was a good reason for that.
What were some of the things that you did with carbon-14 tracer studies? Do you recall some of the particular experiments?
I really don't recall. That was just a dim past. You might wonder how I early on got into chemistry even. I can go back that far. This was, when I was in elementary school, I got involved with building radios and that kind of thing. And they didn't always work. But when I got a chemistry set and followed directions, everything worked. So I think that might have led me into chemistry. There wasn't much chemistry going on around my small hometown, which was Wellington, Kansas, but there were flour mills, and the analytical departments there were doing Kelvil, nitrogen to measure protein content of wheat. I hung around those labs some. And at Kansas State, I did work in the experimentation laboratory, doing some of that same kind of analysis. Also, we now analyzed what went into the cow and what came out as well.
How did you pay for going through school?
Well, I'm an only child. My father had died when I was about 5 years old. My mother just moved to Manhattan and boarded and roomed students. So she assisted me through there. As I mentioned, I worked in the experiment station lab, and in graduate school, of course, I had a teaching and a research assistantship, and the latter one was the Navy. I think it was the ONR that supported my research fellowship.
How would you describe Pitzer as a person?
A little bit austere. I did not have a lot of communication with him. I always felt he was a little bit over my head. He was very kind. He was not demanding. He was very fine research director. But I felt not up to his level, really. That was the problem. I had 2 physical courses from Professor Joke, and his lectures were just fantastic. And I did at that time feel I had a good understanding of chemical thermodynamics. Another interesting professor that we had was Gerald E.K. Branch, and he and Melvin Calvin wrote the book entitled The Theory of Organic Chemistry. And the thing about Professor Branch was he'd come from Manchester, someplace in England, and he still had quite a strong accent. It always took me about 5 minutes into the lecture before I could understand him. But he never used a note. Even over a Christmas holiday, he would come and proceed just where he left off. I don't know how he did it. His lectures were a marvel.
Why did you decide to go into industry?
Well, I don't know, really. I never felt I was a strong aptitude as a teacher, although, in fact, there's a story about that. At Berkeley, we had 10 or 12 freshman lab sections, and the top, they were allocated to the students according to how they had done on a preliminary test. And only the top levels got the ranking professors as their lab coaches. And this was the only recitation sections there were. There was the general lectures for freshman chemistry, but we had an hour of class and 2 hours of lab in the laboratory. And one day, there were tutoring businesses off campus, and one of the fellows couldn't fulfill his assignment, and he got me to do it. And I turned up there, and there were several of my students in this class, so I knew that they weren't getting from me all that they needed, and in fact, they must have been disappointed when they got the same story for additional cost. I did give some courses in Texaco, a 2-week course on catalysis in general at Port Arthur, and another week at the laboratories in Richmond when we had laboratories there, and I gave a series of talks on acidic catalysis at Beacon, in-house.
Who was responsible for Texaco having a good research group when you joined there?
Well, I think it was very much the credit of L.C. Race. He was a trained physicist, actually, and he was so well respected that management allowed him to conduct it in a way that was very similar to academia. We published, well, he had published a number of papers on the determination of pore size distributions from low temperature, nitrogen, and other gas absorption. That would happen before I came. And although we had close discussions with him, and he didn't have so large a group, but what he could follow everything that was going on, and he understood it, he never put his name on our papers. He gave full credit to the people who've done the work.
What caused Texaco to gradually or abruptly change direction of research and emphasis on this kind?
Well, they go through cycles. Part of it, as long as Race was there was no change, although there were budgetary constraints. When somebody from the management, top management, came to Beacon and found that somebody kept their galoshes in a file cabinet, there were to be no more file cabinets. Things like that. I'm now outside of Texaco, but I have contacts, and I think things are much better than they have been in the interval. I think that they're outstanding in their efforts to provide the means for people to do good work and to maintain a high level of morale. I compare it with things that I hear about the more the high-tech industries in electronics and controls and things like that. Many of these have involved, I know this from experiences with family members and so on, that people don't seem to be regarded as persons as much as they used to. That especially in these companies that operate on contracts. When a contract was done, possibly there's no more use for the employee. And it's unfortunate that has happened. Maybe it's always existed, but unfortunately I didn't encounter it.
What was the most satisfying thing you did while you worked at Texaco?
I really don't know. I know that that in research, the things that you achieve, even a small goal, it's very satisfying. And as you go through many failures, which are so you're down at maybe a low level a lot of the time, but the successes make it worth it.
What was your biggest frustrations while you were there?
I don't know whether I want to go into that. There were, even race gave me a little frustration. so I got the order back. But I couldn't find any substitute. So at the end of one day, I just laid the order on his desk again, and it went through.
How did Texaco manage research?
Well, it varied from time to time. In the physical research section, as it was known then, it changed its name. We called it, I think it became catalysis and surface chemistry. I'm not even sure of that. We had to devise a new name for it. But as long as we were there, we were pretty free to outline our objectives. Later, two things came in that some operating department had to support what we were doing. So you made proposals, there were annual meetings where you presented your program, and if you needed someone to pick up the tab on it. When I got into the more applied section, there was, I think, something they called management by objective, and it just didn't seem to me to fit research. If it wasn't a very applied type of problem, you needed a goal, you needed something to do, but it seemed to me that if you're exploring, you can't define the intermediate steps very well, and you need to think about the most efficient approaches, but I couldn't see this as a way to manage research in a detailed way.
What do you think is the biggest change that's happened in industry since you started working in industry?
From what I can hear, it's just that you're speaking of research in the industry, but it really has to pay its way. It has to be more efficient, and in many cases, I don't think there's the freedom to explore new ideas that we used to have.
What did you think when you started working on Catalyst?
Well, I'd heard the definition of a catalyst is supposed to accomplish things without it being changed itself. And I thought it was an opportunity to do something that would be beneficial to the world in general. And rather than make a new product particularly, a better way to achieve some things that are needed.
What was the first big scientific meeting that you remember going to?
Well, American Chemical Society meetings are so big and cumbersome, they don't leave a very distinct impression. I probably is coming here, to the Gordon Conference in the early 50s. But in 1956 was the inaugural meeting of the International Congress on Catalysis in Philadelphia. And that was something that impressed me a great deal, as have the subsequent ones that I got to. The one in Paris in 1960, and I had a paper on that one. I forgot to mention, and it comes back to me that I was looking at the UV spectra of olefins, and I reported on that in Paris. And I did get to the next one, 64 in Amsterdam, and that was a very big meeting as well.
Did you ever get involved in the carbonium ion controversy?
Oh, yes, indeed. I think that really was involved with this UV spectra of olefins. And I had some interpretations. I thought that I was looking at carbonium ions, and there were a number of people that didn't agree with me, and I suspect they were right. I think George Ola worked with the sulfuric acid species, was one that these things are charge transfer complexes rather than the ion. Another man that I was always at odds with was Lefton. I don't know how we came out. We might have ended up in greater agreement. Well, I beginning to recall a few other things that I worked on. One of them was on the reducibility of supported rhenium. And depending on the pre-treatment of rhenium on alumina, say, it is reducible or not. And I found that I could get it more or less completely reduced using a circulating hydrogen consumption method to determine the amount of hydrogen used.
Who was the first big authority that you had an argument with over science?
Big authority. I don't know what I didn't, wasn't taken notice of by very many big ones. I suppose Ola, I don't know. No, there was a man from Lyon in France at the Paris meeting, I think. Right now I can't think of his name.
What was the most satisfying thing you've done in research?
Perhaps, I don't know, I really, at this point, I'm glad I took this route. It's been very good to me, for me. Sometimes I thought other roads might have been a little more rewarding. One of them that I thought of is that on account of food supply for the world, may become a very, well, it is in certain parts, certainly. So I thought maybe agronomy would be a good thing to work in.
What have you done since you retired?
Well, the early years, my wife and I are both only children. We had rather a great deal to do with elderly members of our family. In fact, in my case, I had an uncle who had no other living relatives, and he lived to the age of 104. So it was necessitated our traveling to Florida and to Kansas quite frequently, from Texas. Since then, we've traveled on our own, and we enjoy walking. We walk footpaths in Texas, in England and Switzerland. And recently I've acquired a computer. I somehow escaped making much use of computers. The only instance was using the mercury porosimeter to get large pore distributions. And at that time I was using IBM punch cards. It took about 100 of them to put data into that, which is ancient equipment these days. So I've only had a computer for several months, and I'm struggling with it. It can be frustrating and occasionally very rewarding as well when you do get it to do something you want it to do. I don't know whether I'll ever get. I have about 10,000 travel slides, and I would like to get them on a database, and it would enable me to sort them and pick out the ones I want to look at. But I don't know if I'll ever get that.
Where are some of the places that you've gone that you really enjoyed the most?
In overseas travel, I really enjoy living in Belgium. If we didn't have family here, I could easily live there. Also, I liked England very much, Ireland, Switzerland. My wife's ancestry is Italian, and I made more of an effort to learn Italian and also Netherlands, Dutch language. French baffles me. I just haven't made any progress with French, although I tried to use it at that Paris Congress. I mean, the man that I had the discussion with will come to me, maybe. But anyway, he finally said, "Speak English." So I did. We recently returned from Australia and New Zealand. And although New Zealand seems to be the place that attracts everyone, it has marvelous scenery and it's a very interesting country. We want to go back to Australia because even though we traveled thousands of miles along the east coast, we saw nothing of the interior. And especially fascinating is this small island state of Tasmania. It's a very interesting place.
When you worked on the Manhattan Project, did you know what it was?
Not for a very long time. We had little idea what it was, but we gradually learned from the security people who came around to try to find out what we knew, and in so doing revealed, I feel, much more than we had known before. Our product was this boron trifluoride methyl complex, and we sealed this up in 5-gallon stainless steel cans. It was taken on board of the Pullmans, the sleeping car trains, and I think we learned that it went to cyanamide for breaking it down, and one of the things that puzzled us, we assumed it was being used as a neutron absorber, but cadmium is a very good neutron absorber too, and why they just didn't use that unless they wanted it in a special form, boron provided.
Did your meetings involve meeting with Yuri, or was he far enough removed?
Only occasionally met him, I think, when I first went to Columbia. there was a physicist from Los Alamos who provided the equipment that we used for the neutron absorption method of analyzing our abundance. And I think he built it, or it came from, I don't know where it came from, there or Chicago, and I had trouble with it. And in those days, everyone had this experimental physics book by somebody named Strong, I think. And everyone, if you examine people's books, there'd be a real dirty bunch of pages in the middle. And those were the things for counting tubes. But this piece of equipment that they had given me didn't work very well. I looked at some of the simple circuits in this book, and I tore out about half of the electronics, and it worked fine.
Now, how did you get recruited for the Manhattan Project?
Well, I had just been at Whiting for a month, and they needed somebody. I guess what I was doing wasn't all that critical, so they rushed some clearance through, and I wasn't told what I was going to do until I arrived in New York at the Grand Central Station, and I was met by the person who was to be my supervisor, and he took me up to the adjacent hotel, and I can't remember it. We got in this room, and we crouched in a far corner of the room before he would even tell me what it was all about. And we were cautioned never to use the names of the chemical things we were working with. We had code names for, one of them was synthane, I think that was the complex, and monomer, which maybe BF3, I don't know. They told us don't stand near the edge of the subway platform, but don't obviously carry a briefcase or something. I kind of want to cloak and dagger stuff, which I don't think had much basis.
Now, was the military around in uniform, or were they in civilian?
Those security fellows, I think, were in Army uniform. One of our technicians had been drafted, and he was posted to work with us, and he was not allowed to wear his uniform, so he could not get the advantages which were given to members of the armed forces in uniform. Until very, very much later, I think toward the end, he was allowed to wear his uniform.
Now, did you make the BF3 yourself, or did you just sterilize it?
We got the BF3 in tanks, we got the ether, and we made the complex. This was essentially a distillation, but it was really a association type of thing, and the columns were huge Inconel with Stedman screen packing. We had to be very corrosion resistant, and it was under reduced pressure, so any leaks drew in air and moisture. We had diaphragm pumps which were faced with Teflon. I think it was quite a new thing at the time, and it was quite a large columns were several feet in a cross section, and then it worked down to the small 6-inch column, perhaps.
Who were some of the other people that were working there that you got to know?
At Art Kahn was a federal employee. He was in charge of our project. You know, there's I wish I could think of the man who worked with us too. He's quite well known in mass spectrometry. He recently retired. I can't think of his name. We had several young engineers there. There must have been about 6 or 7 or 8 people in the professional staff, and we had shift workers around the clock on the units. And of course, this material wasn't all that healthy if ingested, so cooking was not allowed, but a big steam hot plate was discovered behind the control panel. After that, they fixed us up with a steam heating device outside the building.
By the time the bomb was announced, were you aware of what you were working on, or were you?
Yes, we were pretty much, but we still didn't tell anybody. Oh, no, I'm not sure we knew it was a bomb. But we knew about uranium. Yes, I think we must have known. We knew about uranium separations. We knew about fission. We knew about all that.